Hello friends, now in this video we will start the question number 2 from the miscellaneous exercise. I will explain all the examples in a very simple language. Now let us start the miscellaneous exercise chapter number 5 question number 2. Solve the following. Find the area of the region bounded by the following curve, x-axis and the given lines. What is the first question? That is x lies between 0 to 5 equal to 0 and equal to 5 also. And y lies between 0 to 2 and equal to 0 and equal to 2 also. Instead of finding with the definite integration, I write in this way, that is the value of x, that is the area of the rectangle is equals to L into B, 5 into 2, that is equals to 10, and this is the required area. Now the next question, y is equals to sine x, the value of x is equals to 0 to x is equals to y. Now see this figure. This is the graph of this y is equals to sine x curve. It's a start from the 0, pi by 2, it has a maximum value. Again the pi, the sine of pi is 0. Now we have the two parts, that is a1 and a2. Therefore capital A is equals to a1 plus a2, that is equals to 2 times a1. And that's why we will calculate the capital A is equals to 2 times 0 to pi by 2 y dx. A1 मधला area आणि A2 मधला area दोन्ही कसे तर सेम आहे. Therefore A is equals to 2, 0 to pi by 2 y dx. That is a 2. What is the value of y? Y is a sine x. 0 to pi by 2 sine x. What is the integral of sine x? Is a minus cos x. Upper limit minus a lower limit, that is a cos of, take the minus sign outside this bracket, minus 2 in bracket cos of pi by 2 minus cos 0 and cos 90 is 0, cos of 0 is a 1. That is minus 1 and minus 2 and minus 1, that's equals to 2, and therefore area is equals to 2. Now the next, y is equals to sine x. The value of x varies from x is equals to 0 to x is equals to pi by 3. Here the required area, see this curve, this is the curve y is equals to sine x. At the point x is equals to 0, it's a 0, its a value is 0. At the point x is equals to pi, its value is 0. But our required limit is x is equals to 0 to pi by 3. Therefore required area is equals to 0 to pi by 3 y dx. What is the value of y? Is a sine x, and the integral of sine x is minus cos x 0 to pi by 3. That is minus cos of pi by 3 minus cos 0. But what is the cos of pi by 3? Cos 60 is 1 upon 2 and cos 0 is 1. That is 1 upon 2 minus 1. That is minus half, and again here is a minus sign. Minus minus will become plus, and that's why a is equals to 1 upon 2. Required area is equals to 1 upon 2. Find the area of the circle. X square plus y square is equals to 9 using the integration. We can find out this area by using our formula, that is the area of the circle is equals to pi r square. But how to find out? By using the integration. Now see this is the standard circle whose center is at the origin 0, 0. And the radius of this circle is a 3. We first find out the area of the first quadrant and then multiply it with by the 4. Now see this here, x square plus y square is equals to 9. Therefore y square is equals to 9 minus x square. That's why y is equals to in root of 9 minus x square. The area of the circle is equals to 4 times integral 0 to y dx. Now 4 times 0 to 3 in under root of 9 minus x square dx. Now what's the integral of in under root of a square minus x square? That is a x upon 2 in under root of 9 minus x square plus 9 by 2 sine inverse of x upon 2 0 to 3. Now substitute x is equals to 3. That is a 4, that is in bracket 3 by 2 in bracket, that is a 9 minus x square. That is a x is equals to 3, 9 minus 9, that is equals to 0. 0 into 3 by 2, overall you will get 0. Here is a 9 by 2. Sine inverse of 3 upon 3, that is a sine inverse of 1. But what is the value of sine inverse of 1? It is a pi by 2 into 9 by 2 and again into 4. That is a 4 into 9 by 2 into pi by 2. And you will get, that is the value, that is the area of the circle is a 9 pi. It's a clear that the area of the circle is a pi r square. What's the r here? R is a 3 and it's a square is a 9 pi. Therefore the area of the circle is a 9 pi. Now the next, Find the area of the ellipse, that is x square upon 25 plus y square upon 16, that's equals to 1. Before that, we have also calculate the area of the ellipse is pi AB. What is the value of A is 5. Value of the B is 4, and 5 into 4, that is 20 pi AB. That's we can find out it. Now see this. This is the ellipse. Its major axis is along the x-axis, minor axis is along the y-axis, and these are the coordinates. X varies from 0 to 5. Now see this, the equation of the ellipse, x square upon 25 plus y square upon 16 is equals to 1. Therefore y square is equals to 1 minus x square upon 25 bracket completed into 16. Therefore y square is equals to 16 upon 25 in bracket 25 minus x square. Take the square root on both sides, then you get y is equals to plus or minus 4 upon 5 in bracket 25 minus x square. Therefore, the required area is equals to 4 integral 0 to 5 y dx. That is equals to, but what is the value of y? We take it as a plus sign. That is a 4 integral 0 to 5 4 by 5 in under root of 25 minus x square dx. That is equals to 16 upon 5 0 to 5 in under root of 25 minus x square. But again we will apply here the formula. What is that formula? Integral in under root of a square minus x square. It's a formula that is a x upon 2 in under root of a square minus a square plus a square upon 2 sine inverse of x upon a. Here the value of a is 5, a square is 25. Therefore 16 upon 5 in bracket x upon 2 in under root of 25 minus x square plus 25 upon 2 into sine inverse of x upon 5 0 to 5. Now substitute upper limit minus lower limit. If we substitute x is equals to 5 here, then 25 minus 25, x square means 25. That is a 5 square means 25. 25 minus 25, that will become 0. 0 into x by 2. That is overall it is 0. What about the next 25 upon 2 sine inverse of 5 upon 5, and lower limit is a 0. Overall that will become 0. Now here 25 upon 2 sine inverse of 1. Sine inverse of 1 is pi by 2. And that's why here 16 upon 5, 25 upon 2, sine inverse of 1 is pi by 2. And if you simplify this, and then you will get, that is a 2 into 2, 4. 16 upon 4 is a 4. 25 upon 5 is a 5. And therefore the answer is a 20 pi. This is the required area of the ellipse. Now the next problem, find the area of the region lying between the parabola, that is a y square is equals to 4x and x square is equals to 4y. These are the two parabolas and they intersect at the point B and as well as at the 0. The point of intersection is a 4 and 4. Just we have calculated this type of the area in our MCQ question also. Now first we will find out the area below the parabola y square is equals to 4x and the area below the parabola x square is equals to 4y. If you find out the area below the parabola y square is equals to 4x minus area below the parabola x square is equals to 4y. Now let us see this here. Point of intersection, that x square is equals to 4y there and the y square is equals to 4x. X is equals to y square upon 4. Now substitute the value of x here. What is the value of x? Is a y square upon 4 bracket square is equals to 4y. That is a y raised to 4 upon 16 is equals to 4y. And if we make the cross multiplication, y raised to 4 minus 64y is equals to 0. Take y as a common, then in bracket you will get y cube minus 64, that's equals to 0. That is y, what are the factors of y cube minus 64? That is a cube minus b cube. Its factors are in first bracket y minus 4 and second bracket y square plus 4y plus 16, that's equals to 0. Therefore y is equals to 0, y is equals to 4. That is y square plus 4y plus 16, we cannot factorize it. The factors are imaginary. Therefore here we have the 2 points, that is the y is equals to 0 and y is equals to 4. When y is equals to 0, put substitute in the equation of the parabola, then you will get x is equals to 0. When y is equals to 4, then substitute here, that x is equals to y square upon 4. 16 upon 4, that is equals to 4. And that's why we have the point of intersection of these two parabolas are 0, 0 and 4, 4. Here is the point of intersection 0, 0 and the 4, 4. These are the intersections of these two parabolas. Now we'll find out the area below the parabola y square is equals to 4x in the first quadrant. Y square is equals to 4x here below the parabola. That is, it is in the first quadrant. Therefore, a1 is equals to 0 to 4 y dx equals to 0 to 4. What is the value of y square is equals to 4x? Take its a square root. That is the root of 4x. What is the root of 4? That is a 2. Integral 0 to 4 root x. What is the integral of root x? That is x raised to 3 by 2 upon 3 by 2. It means 2 by 3. That is a 2 into 2 by 3 into x raised to 3 by 2. Upper limit is a 4, lower limit is 0. Substitute x is equals to 4 and x is equals to 0. Lower limit is 0, it doesn't matter. Now here 4 raised to 3 by 2 means what? 4 means what? 2 raised to 2. These 2 get cancelled, you will get 2 raised to 3. And 2 raised to 3 is 8. That is a 4 upon 3 into 8. And therefore you will get a1 is equals to 32 upon 3. Now a2, the area below the parabola x square is equals to 4y in the again first quadrant. That a2 is equals to 0 to 4y dx, 0 to 4 x square upon 4 dx. Now its integral is x cube upon 3, that is 0 to 4. Substitute x is equals to 4 and then you will get 1 upon 12, that is a 64 is equals to 16 upon 3. This is the a2 area. Now the required area is equals to capital A is equals to a1 minus a2. 32 upon 3 minus 16 upon 3. That is equals to 16 upon 3. This is the area. Now the next question, that is the 4y square is equals to 9x and 3x square is equals to 16y. Again we will find out the point of intersection between these two parabolas. One is a 0, 0 and another we will find out that b coordinate. Again we will find out the area below the parabola 4y square is equals to 9x and area below the parabola 3x square is equals to 16y, and make their subtraction. You will get the required area. Now 4y square is equals to 9x and 3x square is equals to 16y. Therefore y is equals to, that is a 3x square upon 16 from this parabola. And substitute the value of this y is equals to 3x square upon 16 in this parabola. That is a 4y square is equals to 9x. If we substitute it, then you will get 4 in bracket 3x square upon 16 whole bracket square is equals to 9x. Therefore 3x square upon 16, it's a bracket square means what? 9x raised to 4 upon 256. Now minimize it, simplify it, then you will get that is x raised to 4 is equals to 64x. Now take x as a common, then in bracket you will get x cube minus 64, that's equals to 0. Now again the factorization factors, that is a cube minus b cube. In first bracket x minus 4, in second bracket x square plus 4x plus 16, that's equals to 0. Therefore the factors are, that is the values of the x are x is equals to 0, x is equals to 4. Again x square plus 4x plus 16, the factors are imaginary, we cannot consider here. Therefore when x is equals to 0, y is equals to 0. When x is equals to 4, then what about the y? Y is equals to 3x square upon 16. That is replace x by 4, then you will get 3 into 4 square upon 16. Let's see, if you simplify, then you will get y is equals to 3. Therefore x is equals to 4 and y is equals to 3. This is the point of intersection of the parabola. What is the point of intersection? Again you can see this here 0, 0 and the another points are 4 and 3. Here is a coordinate of B are 4 and 3. Now we'll find out the area below the parabola. 4y square is equals to 9x in first quadrant. Now 4y square is equals to 9x, therefore y square is equals to 9 by 4x, therefore y is equals to 3 by 2 into root x. Substitute here 0 to 4 y dx, 0 to 4 3 by 2 root x dx. Now here is a 3 by 2. What is the integral of root x? X raised to 3 by 2 upon 3 by 2. It's become multiplied and reciprocal, and here 3 by 2, this 3 by 2 get cancelled. You will get x raised to 3 by 2, lower limit is 0, upper limit is 4. Substitute x is equals to 4, that is a 4 raised to 3 by 2, lower limit is 0. That is 4 raised to 3 by 2 means what? 2 raised to 2 bracket raised to 3 by 2. This 2 get cancelled, 2 raised to 3, and that's for a1 is equals to 8. What about the area a2? The area below the parabola 3x square is equals to 16y. In first quadrant, that is a 0 to 4 y dx, 0 to 4 3 upon 16 x square dx, and that's why you will have, that is a 3 upon 16 into x cube upon 3, 0 to 4. Substitute x is equals to 4, that is a 3 upon 16. These 3 get cancelled, 1 upon 16, 4 is to 3, x is equals to 0. 4 is to 3 means what? That is 64 upon 16. That is equals to 4. That is 64 upon 16. That is equals to 4. And therefore A2 is equals to 4. Therefore the required area is equals to A1 minus A2. That is 8 minus 4. That is equals to 4. Now this is my answer. That is there is a correction in the textbook, but this is my answer. That is the required area. A is equals to 4. If you are agree, then understand this. Now the next is y square is equals to x and x square is equals to y. Y square is equals to x and x square is equals to y. Find the point of intersection again. Now substitute the value of y here from the second parabola. What's the value of y? Y is x square. Substitute here y. That is x square and whole bracket square, that is equals to x. X raised to 4 minus x. Again take x as common, then in bracket you will get x cube minus 1. That's equals to 0. X is equals to 0. X minus 1 in first bracket. Second bracket x square plus x plus 1, that's equals to 0. We'll consider only the real factors, that is x is equals to 0 and x minus 1 is equals to 0. X is equals to 0 or x is equals to 1. Corresponding y coordinates are, it's very real, that's real that when y is equals to 0 and corresponding y coordinates are the y is equals to 0 and y is 1. Therefore the point of intersection of that two parabolas here 0 0 and 1 1. Now see this figure. Again we'll find out the area below the parabola, area below this parabola, and then make their subtraction. Now the area below the parabola y square is equals to x in the first quadrant, that is a1. Y is equals to root x. A1 is equals to 0 to 1 y dx. What is the value of y? It's a root x dx. And its integration is a 2 by 3 x raised to 3 by 2 0 to 1. Therefore A1 is equals to 2 by 3. Lower limit is upper limit is 1 and lower limit is 0. Therefore A1 is equals to 2 by 3. What about the A2? That is the area below the parabola x square is equals to 1. 0 to 1 by dx. That is a 0 to 1 x square dx. X cube upon 3 0 to 1. Now find out its value. That is integral of x square is x raised to 3 upon 3. Substitute x is equals to 1 and x is equals to 0. Therefore A2 is equals to 1 upon 3 minus 0. And that's why A2 is equals to 1 upon 3. All these problems we have discussed in the MCQ questions also. Here is a A2 is equals to 1 by 3. Therefore required area is A1 minus A2. That is a 2 by 3 minus 1 upon 3. That is equals to A is equals to 1 upon 3, and this is the required answer. Now the problem number 5. Now here is a problem number 5. Find the area of the region in the first quadrant bounded by the circle x square plus y square is equals to 4 and the x-axis and the line x is equals to root 3y. First we will find out the point of intersection of the parabola and the required line. X square plus y square is equals to 4 and x is equals to y root 3. Put x is equals to y root 3 and y root 3 bracket square plus y square is equals to 4. 3y square plus y square is equals to 4. 4y square is equals to 4. Y square is equals to 1. Y is equals to plus or minus 1. When y is equals to 1 and x is equals to y root 3. Put x is equal y is equals to 1 and then you will get x is equals to root 3. Y is equals to 1 and x is equals to root 3. Now see this here. This is the circle and the line is here. The point of intersection, that is a root 3 1, and here is a, we will find out these two areas. Now see this here again. That is first I had marked with the red ink and another is with the blue. First we will find out this area, that is the area below this line up to the point where x is varies from x is equals to 0 to root 3. And next I will find out the area below this circle where the value of x varies from x is equals to root 3 to x is equals to 2. Now let us start. That is a1 is equals to area below the line, x is equals to y root 3. What is the value of y? That is integral 0 to root 3. What is the value of x? X varies from x is equals to 0 to x is equals to root 3. Therefore 0 to root 3 y dx, 0 to root 3 x upon root 3 dx. Now again integral of that is integral of x. Integral of x is x square upon 2, 0 to root 3, 1 upon root 3. Substitute x is equals to root 3, then the root 3 square, that is equals to 3. That is 1 upon 2 root 3 into 3. And then you will get, that is a 3 upon root 3. 3 means what? Root 3 into root 3. 1 root 3 will get cancelled. And you will get root 3 upon 2. This is the A1. That's equals to root 3 upon 2. This is the first one. What about the second? A2. Area below the circle in the first quadrant. And the value of x, y. X varies from root 3 to 2. Now see this here. The value of x varies from root 3 to 2. And now we'll find out the integral root 3. The value of x varies from root 3 to 2. Now see this here. Now see this here. A2 is equals to area below the circle in the first quadrant, and therefore values of x varies from root 3 to 2 y dx. Now see this here. The equation of the circle is x square plus y square is equals to 4. Therefore y square is equals to 4 minus x square, and that's y is equals to in root of x square 4 minus x square. Now substitute the value of the y here. Integral varies from, that is the lower limit is root 3, upper limit is 2, in root of 4 minus x square dx. Now again we will apply here formula, that is in under root of a square minus x square. That is x upon 2 in under root of 4 minus x square plus, that is a square upon 2, that is a 4 upon 2 sine inverse of x upon 2. Lower limit is root 3, upper limit is 2. Now substitute here, x is equals to 2. That this first bracket will become 0 plus, and next replace x by root 3, that is a minus. Here is again 4 upon 2 means what? Here is a 2. Sine inverse of 2 upon 2 means what? Sine inverse of 1. Minus lower limit, put x is equals to root 3. That is a root 3 upon 2 in under root of 4 minus root 3 square means what? 3 minus 2 sine inverse of root 3 upon 2. Now see this here. Sine inverse of 1, that is a pi by 2. That is a 2 into pi by 2 minus root 3 upon 2. In under root of 4 minus 1, that is a 1 minus 2 sine inverse of root 3 upon 2, that is a pi by 3. And if you calculate here, these two get cancelled and you will get pi minus, here is a root 3 upon 2 minus 2 pi upon 3. That is, here is a pi minus 2 pi upon 3 minus root 3 upon 2. And if you calculate, that is a pi minus 2 pi by 3. If you simplify it, that A2 is equals to pi by 3 minus root 3 upon 2. This is the A2 area. Therefore, now A is equals to A1 plus A2. And that's why A is equals to A1 plus A2. Root 3 upon 2 plus pi by 3 minus root 3 upon 2. The plus root 3 upon 2 minus root 3 upon 2 get cancelled, and A is equals to pi by 3. Now the next problem number 6. Find the area of the region bounded by the parabola y square is equals to x and the line y is equals to x in the first quadrant. Now first find the point of intersection of the parabola y square is equals to x and y is equals to x. Put y is equals to x in this equation, then you will get x square is equals to x. X square minus x is equals to 0. Take x as a common. Then you will get that x in bracket x minus 1, that's equals to 0. X is equals to 0 or x minus 1 is equals to 0. Therefore, x is equals to 0 or x is equals to 1. Corresponding y coordinates are 0 or y is equals to 1. If you substitute, then you will get. Therefore, these are the point of intersection of these two parabolas. First is the 0, 0 and 1, 1. Now we'll find out the area below the parabola y square is equals to x and the area below the line y is equals to x and make their subtraction. Therefore, the required area is in the first quadrant. That is capital A is equals to A1 minus A2, area below the parabola minus area below the line. Therefore, integral 0 to 1 y dx for the parabola. Integral 0 to 1 y dx for the line. But what is the y is equals to? For the parabola is root x and for line y is equals to x. And here is a y square is equals to x, y is equals to root x. Find out the integral of root x, which is x raised to 3 by 2 upon 3 by 2. It's become multiplied and reciprocal and it's become 2 by 3. Lower limit is 0, upper limit is 1. If you substitute x is equals to 1, then you will get 2 by 3 into 1 minus. Substitute here, upper limit is 1, that is 1 upon 2. Lower limit is 0. Therefore, 2 by 3 minus 1 upon 2. And if you simplify it, make the cross multiplication, that is a 4 minus 3, that is equals to upon product of 3 into 2, that's a 6. That is equals to 1 upon 6. Therefore, the required area, capital A is equals to 1 by 6. Now the problem number 7. Find the area enclosed between the circle x square plus y square is equals to 1 and the line x plus y is equals to 1 lying in the first quadrant. Now see this here. We'll find out the area below the circle minus area below this line in the first quadrant. First we'll find out that it's clear that the given line is x plus y, that's equals to 1 point of intersection. That is the coordinate of A is a 1 0 and the coordinate of B is a 0 1. The values of x varies from x is equals to 0 to 1. Now let us start. A1, the area below the circle in the first quadrant, that is integral 0 to 1 y dx. What's the value of y? The value of y, that is x square plus y square is equals to 1. That is y square is equals to 1 minus x square. Therefore, y is equals to plus or minus in under root of 1 minus x square. But we are considering the first quadrant, therefore we take the plus sign. Therefore, integral 0 to 1 in under root of 1 minus x square dx. Now see this here, 0 to 1 in under root of 1 minus x square dx. Now this type of the formula again repeating. That is integral in under root of a square minus x square. That is x upon 2 in under root of 1 minus x square plus 1 upon 2 sine inverse of x. Lower limit is 0, upper limit is 1. I had repeated this formula, that is in under root of a square minus x square. Now substitute x is equals to 1 and x is equals to 0. Upper limit is 1, that is a 0, plus sine 1 upon 2 sine inverse of 1 minus lower limit is 0. Complete it is a 0. That is a 0 plus 1 upon 2 sine inverse of 1. What is the value of sine inverse of 1? Is pi by 2 into 1 upon 2. That's a pi by 4. And therefore A1 is pi by 4. Area below the line in the first quadrant. That is integral 0 to 1 y dx. But what is the line? Line is x plus y, that is equals to 1. Therefore, y is equals to 1 minus x into bracket complete into dx. What is the integral of 1? Integral of 1 is x. What is the integral of x? X square upon 2. Lower limit is 0, upper limit is 1. And if you substitute x is equals to 1 and x is equals to 0, then you will get 1 minus 1 upon 2. That's equals to 1 upon 2. A2 is equals to 1 upon 2 and therefore required area is A1 minus A2. That's equals to pi by 4 minus 1 upon 2. And next problem. That is a find the area of the region bounded by y minus 1 bracket square is equals to 4 in bracket x plus 1. And the line y is equals to x minus 1. Here the vertex of the parabola is a different one. That is, this is the parabola whose vertex is a minus 1 and 1. We have learned in the conic section in 11th standard, this vertex is not 0, 0. Its vertex is a minus 1 and 1. Now, this is the parabola whose vertex is minus 1 and 1. Now, the point of intersection of the parabola and the line y is equals to x minus 1. Put y is equals to x minus, that is, substitute the value. That is, we will find out the point of intersection. Y minus 1 bracket square is equals to 4 in bracket x plus 1. That is here. That is a 4 in bracket. Value of the y is x minus 1. Therefore, if we substitute this value x minus 1 bracket square is equals to 4 in bracket x plus 1. X minus 2 bracket square is equals to 4 in bracket x plus 1. Now expand this. That is x square minus 4x plus 4. That is equals to 4x plus 4. Plus 4 on both sides get cancelled. And here is x square minus 8x is equals to 0. Take x as common. And in bracket you will get x minus 8 is equals to 0. Therefore x is equals to 0 or x minus 8 is equals to 0. X is equals to 0 or x is equals to 8. When x is equals to 0, what about the y? Y is equals to x minus 1. And put x is equals to 0, then you will get y is equals to minus 1. What about the point B? The point B, that is a 0 and minus 1. When x is equals to 8, what about the y? Y is 7. And therefore, this is the point of intersection of these two parabolas. Now see this here. This problem, that is, in this parabola, we have the three areas, that is A1, A2 and A3. Now we'll find out the areas of these parabola, of these sections, that is the A1, A2 and the A3. Now let us start. As the vertex of this parabola is a minus 1 and 1, we have these three types of the areas. This is the A1, A2 and again I am repeating A3. Now we'll find out it first. First find the area A1. Which is the area A1? O, E, C, F, O. What is here? Here is a O, E, C, F, O. OECFO, area A1. Now see this here. That is area below the parabola in the first quadrant minus area below the line y is equals to x minus 1. Area below this parabola and minus area below the line. That will be the required area A1. Therefore, now see this here. That A1 is equals to area below the parabola. That is the value of x varies from 0 to 8 y dx. And the value of here x varies from x is equals to 1 to 8. That is area below the line. Now see this here. How that values varies. That is first is x is equals to 0 to 8 and second is x is equals to 1 to 8. How they are, that values are. Now here the values of this parabola, x varies from x is equals to 0 to x is equals to 8. What about the line? The line start actually from here. That is x is equals to 1 to x is equals to 8. Therefore, I had taken their limits as first is 0 to 8 and second is 1 to 8. And therefore, substitute the value of y, that is the parabola, that is y is equals to 2 in under root of x plus 1 brackets complete into dx. Then how this is? That is y minus 1 bracket square is equals to 4 in bracket x plus 1. Take the square root on both sides, then you will get y minus 1 is equals to 2 in under root of x plus 1. Therefore, y is equals to 2 in under root of x plus 1 plus 1. And this is the value of y. Now, what about the next? For the line, it's very simple. That is y is equals to x minus 1 dx. And now integrate this. Now, what is the integral of in under root of x plus 1? That is x plus 1 raised to 3 by 2 upon 3 by 2. It's become 2 by 3. Integral of x is 1. 0 to 8 minus x minus 1 bracket square upon 2. Lower limit is 1, upper limit is 8. And substitute x is equals to 8. That is a 2 into 2. That is a 4 upon 3. X is equals to 8. 8 plus 1. That is a 3 by 2 plus 8 minus. And again substitute here x is equals to 8. 8 minus 1. And it is a, if we substitute here for this integration. If we substitute here again x is equals to 0 here. Then you will get 0. That is a 2 by 3. 1 raised to 3 by 2. And again here is a 0. This is the for the parabola. What about the line? Put x is equals to 8. That is 8 minus 1 bracket square upon 2 and x is equals to 0. If we substitute x is equals to 1, then 1 minus 1 that will become 0. 0 upon 2 and overall it will become 0. This is for the line and this is for the parabola. Now see this here 2 into 2, 4. That is 4 upon 3 or 2 into 2 by 3. 9 raised to 3 by 2 plus 8 minus. What about here? 2 into 2, 4. 4 upon 3 minus 8 minus 1. That is a 7. 7 raised to 2. 49 upon 2 minus 0. Again see this here. 2 into 2 by 3 into 9. 9 bracket is to 3 by 2. That is again here. 9 means what? 3 raised to 2. These 2 get cancelled and you will get 3 raised to 3 means what? 27. And here is a 3. We'll again simplify and then you will get that is a 2 into 2 into 9 plus 8 minus 4 upon 3 minus 49 upon 2. Now here is that 49 upon 2. 2 into 2 into 9 plus 8 minus 4 upon 3. And if you simplify it, then you will get 36 plus 20 upon 3 minus 49 upon 2. That is 36 plus 40 upon 1, 47 upon 6, and you can simplify it also. Therefore, you will get 36 minus 107 upon 6. That is the 216 minus 107 upon 6. Therefore, A1 is, that is a 109 upon 6. Now, the area below the parabola, we will calculate the area A2. Where is A2? Now, see this here, A2. This is the A2, that is the area below this parabola. Now, the values of x will varies from x is equals to minus 1 to 0. Now, see this here, A2, we'll calculate the A2. This is A2, x is equals to minus 1 to x is equals to 3, sorry. This is the value of x, and again x is equals to minus 1 to x is equals to 3. The substitute, we take the as the variable as a y, and therefore the value of y varies from y is equals to minus 1 to 3. Now see this here, we are taking integration, that is y is equals to minus 1 to y is equals to 3. Find out this area and see this here. A2, y is equals to minus 1 to y is equals to 3. Minus 1 to 3. And the value of x, that is y minus 1 bracket square upon 4 minus 1. And here is you will have its integration y minus 1 bracket cube upon 12 minus 1. Lower limit is minus 1, upper limit is 3. Substitute y is equals to 3. 3 minus 1 bracket cube upon 12 minus 3. Lower limit is minus 1. That is minus 1 bracket is to 3 upon 12 minus in bracket minus 1. And that's why that is a 2 minus 3 minus 1. That is a 2. 2 raised to 3 means what? 8. 8 upon 12 minus 3 minus 8 upon 12 plus 1. And here is a, if we open this bracket, you will get plus 8 upon 12 minus 1. And that is a 8 upon 12 plus 8 upon 12. That is a 16 upon 12. Minus 3 minus 1 minus 4. And that's why you will get that is a 4 upon 3 minus 4. And therefore you will get minus 8 upon 3. Area is always positive. Therefore A2 is equals to 8 upon 3. And this is the second one. Now we'll calculate the area A3. That is the area of the region BEOB. Now see this area. This is the area A3. Area A3. This is the area. That is a BEOB. This is the area. That's nothing but the area of the triangle. You can see this here. And that area is a simple one. Here is that area. That is the area BO. That is the integral 0 to 1 y dx. And that is y is equals to x minus 1. And therefore 0 to 1 x minus 1. The value of x varies from x is equals to 0 to 1. And its integral is x minus 1 bracket square upon 2. Lower limit is 0, upper limit is 1. X is replaced by first of all 1 minus 1 0 bracket square upon 2 minus 0 minus 1 bracket square upon 2, and that's equals to minus 1 upon 2, and therefore A3 is minus 1 upon 2. But area is again positive, always positive. Therefore A3 is equals to 1 upon 2. Therefore from 1 to 3 the required area capital A is equals to A1 plus A2 plus A3. That is 109 upon 6 plus 8 upon 3 plus 1 upon 2. And if you can simplify it, and then you will get that is a 128 upon 6. That is nothing but the 64 upon 3. This is my answer. That the answer from the textbook is a different one. If you are agree, then write down this. Okay. Now the problem number 9. Find the area of the region bounded by the straight line 2y is equals to 5x plus 7 x-axis and x is equals to 2, x is equals to 5. Now see this here. This is the required area. That we will calculate the area below this line where x varies from x is equals to 2 to 5. It's very simple. That is the capital A is equals to x is equals to 2 to x is equals to 5 y dx. The value of y is 1 upon 2 5x plus 7. Now take its integration. That is 1 upon 2 5x square upon 2 plus 7x. Lower limit is 2, upper limit is 5. Substitute it. Then you will get 1 upon 2. 5 into 5 square upon 2 plus 7 into, substitute it. 7 into 5. This is the upper limit minus lower limit 2 into 2 square upon 2 plus 7 into 2. And if you simplify, then you will get 1 upon 2. 125 upon 2 plus 35 minus in bracket 10 plus 40. And that's you will get 1 upon 2. 125 upon 2 plus 35 minus 24. That is 1 upon 2 in bracket 125 upon 2 plus 11. And that's equals to 1 upon 4, 125 plus 22, and overall you will get the area is that is 147 upon 4, and that's nothing but the 36 and 3 by 4. This is the required area. And the now next problem, find the area of the region bounded by the curve y is equals to 4x square x-axis and the lines that is y is equals to 1 to y is equals to 4. Now see this the parabola y is equals to 4x square, that is x square is equals to 1 upon 4y. Now we have the values of the y varies from y is equals to 1 to 4, and therefore we will take required area y is equals to 1 to 4 x dx. X square is equals to 1 upon 4y, and therefore x is equals to 1 by 2 root y. Therefore y is equals to 1, y is equals to 4, 1 upon 2 root y into dy. Take 1 upon 2 as a common, that is 1 to 4 in root of y dy. That is the root of y. It's a y raised to 3 by 2 upon 3 by 2, or it's become multiplied and reciprocal. It's a 2 by 3 here. Lower limit is 1, upper limit is a 4. Substitute y is equals to 4 here. upper limit minus lower limit. That is one. Here is again one more thing is that this 2 get cancelled, and then you will get 1 by 3, 4 raised to 3 by 2 minus 1 raised to 3 by 2. Now see this here, 1 by 3, 2 raised to 2, bracket is to 3 by 2 minus 1. This 2 get cancelled, you will get 2 raised to 3. 2 raised to 3 means what? 8, 8 minus 1. And therefore 1 by 3, and here is a 7. That is equals to 7 upon 3, and this is the required area. And in this way, we have completed the miscellaneous exercise for the chapter number 5. Now we'll see in the next video. Till then, goodbye.